Okay, on the bench today I have kind of hard to see, it's taped up, but it's a Stryker SR-497HPC. Another tech sent this in to me, so the person that sent this to me isn't the customer either. It's apparently this has been to a couple other techs and it got to him, and fortunately he knew, yeah, too much for me. I need to send it to somebody else that can fix it. So it's finally ended up on my bench, which I seem to be getting a lot more stuff like that. And I think one of the reasons I'm getting a lot more stuff like this is because of its design, which is surface mount. So now that guy did the right thing. If you don't know what you're doing, the best thing to do is exactly that, nothing. It is so easy to screw up a surface mount circuit board and turn a repairable radio into a pile of useless parts. So, like I say, thumbs up to that guy. He knew enough to say, that's it, I need to send it to somebody that can actually work on this thing. So it's made it to my bench. Problem was no RF output power. Now, actually, it does have a little bit of RF output power. It's, I guess you could say, barely enough to tickle a power meter, but there is a little bit getting there. Now, this is I don't work on the Strykers, that often. Occasionally, I'll get one, but I think the newer ones have 6 MOSFETs for final. Well, not for finals. There's actually 4 finals. So basically, it's a standard radio to this point, and then built-in amplifier back here. So there'd be, actually the 4 MOSFETs sitting right there have been removed. But what you have is basically a standard radio up to here. So you have a driver and a final, and then that drives the 4 MOSFETs back here. Now, my understanding is most of the newer ones use 6 MOSFETs. 6 on the amplifier, and then what I would consider a final is a MOSFET, and the driver is. This one's not like that. This has 4 MOSFETs here, has a MOSFET here, but uses a 2SC2078 here as the driver, which that's that's the same as a final for like a Cobra 29. So, still no biggie. Now I did verify, like I say, we are having output problems, very, very low output power, barely measurable. Now the reason I pulled the MOSFETs was, first thing I did was took some voltage measurements, and the voltage measurements for the finals, they're just all over the map, and I can see where someone had, because I think, if I'm not mistaken, I think the tech that sent it to me said these had been replaced. I'm not actually sure if they have. I think he said the customer might have told him. I don't think he did it. And the reason I say that is the heat transfer grease that I just cleaned off of these and off of the the heat sink here is not the same grease that's stuck on the bottom of this transistor. And this stuff here is a lot drier, like it's almost the original. So I don't know, these may actually still be the original MOSFETs, but and yes, I'm wearing a anti-static foot strap, so I am grounded. I can safely handle MOSFETs. But like I say, my voltages were all wrong, and the more I get to looking at this thing, I can see someone's been reflowing solder, and if you look over here at what I would call, I don't know if they call that a final or a or a driver. They might consider this the driver, or pre-driver, driver, and then finals. I'm not sure, like I said, I'm not sure what they use for terminology, but in any case, someone has been doing a lot of resoldering on this thing, and I'm not sure if it's going to show up very well at all. You can see it a little bit. Let me pull back and try zooming in. I don't think it's going to show up in the camera very well. Yeah, the particles are so small it doesn't really show up that well. But all in here, this is flux residue, but I can see within that flux residue, if you see like right there, tip, there's a little tiny black spot. There's little tiny black spots all over the place, and that includes the 2078 here, and the MOSFETs they're the finals were the same way. It looks like someone used solder paste, but they didn't, which is proper for using with surface mount components. But when you use soldering paste, you have to use a hot air gun to melt that solder. If you try using a soldering iron, and I speak from personal experience years ago when I first tried that stuff, and I'll tell you exactly what happens. You'll put solder paste on here, you hit it with your soldering iron, and half of the solder because you have to remember it's basically powdered solder mixed in with soldering flux paste. Well, a lot of those little solder balls basically get carried away and they're trapped in this flux. Well, when you're using hot air, excuse me, when you're using hot air, it heats the entire area and all that solder will melt, congeal together, and come in and stick to the actual component lead. When you use a soldering iron, actually half of the solder is trying to run away from it because it's flowing away with that solder flux. As it liquefies even more, a lot of those little balls are starting to flow and you end up with shorts. So, like I say, it's having problems. So, the first thing to do, I removed, and I get the feeling it might be a problem. Like I say, I'm just in the beginning stages of diagnosing this thing. I just needed to pull these out. It's one of those, when you follow behind, God knows how many other people's work, a lot of times it's just best to start from scratch. Especially on multi-layer boards. Now this is only a 2-layer board, so it's not a 3-layer board. But even still, when you're working on stuff like this, a lot of times I'll just completely desolder, remove the parts, clean up the soldering pads. That way I can actually inspect them to make sure I'm not having problems with pads or shorted traces, because I can't see through any of this flux residue, if there's shorts or what, I can't see what the hell's going on here. I can tell that these have been resoldered back here, because if I look really close, I can actually see charred. There's a tiny bit of circuit board damage, not just trace, it's the board. You look right here, you can actually see those little little lines there. They've actually broken through the top layer of the fiberglass substrate underneath the trace there, and that's actually dipped down there. There's actually a little bit of board damage there. So yeah, somebody's had to board a little bit too hot here when they were soldering. So, well, like I say, this is the best thing to do. Remove the components. That way you can get in here, clean off the board so it's nice and clean, makes for very easy inspection. And I just can't overstate it enough. If you don't know what you're doing with these boards, either learn or stay away from them. So, like I said, I get a feeling I'm having some problems that some of these pass through some bad solder joints. A lot of these type radios, I'm starting to see. I just, matter of fact, just did a what the hell was that thing? A Max Log here, not too long ago. It was having problems at some of the throughs. You'd have, matter of fact, it was having a problem in the final section with that one as well. And I was having the same problem. No voltage on one side of the board, but voltage on the other side of the board. That's because there were broken solder, it knows the actual throughs were broken. And the problem is, I think with a lot of these radios, I don't want to say it's bad design. I mean, it kind of is, but it's more damage caused by people not knowing how to work on them than I think it is actually bad manufacturing process. Because this does look to be actually a very nice, well-made board. It's actually very rigid. It looks like it's a nice, thick board. Good, nice silk screening. It's professionally made. I mean, it looks like a good, high-quality board. The little bit of damage here, that's not manufacturer's fault. That's somebody using too much heat on a board for too long a time. But, like I say, people get in here with these blazing hot, one-temperature soldering irons where they can't adjust the temperature, and they just end up cooking stuff. So, I just wanted to start here. Like I said, I know I'm already into the process a little bit, but I wanted to show you some of the stuff to keep an eye out for. And what I'm going to do is, anywhere where I can see someone has reflowed solder, at a lot of these pass-throughs here, where components are sticking through, I'm I'm just going to desolder them. I'll remove the part, clean the board up really well, and then resolder them. And then when I resolder them in, I know they're done properly. There's no question in my mind. I'm not, later on in the diagnostic procedure thinking to myself, oh God, is there maybe a bad trace or something over here? Once I redo it, I know it's fine because I'll test it and see that. So let me get on with the repair here and we'll see what we find. Okay, so now that I actually have the circuit board cleaned off on the underside and some of the goop that was on the top side from previous work, I can actually see what I'm looking at. And I did just discover something that's definitely going to cause a problem, at least with two of the final transistors on this side. Okay, so we have an output transformer here. That's what this circuit here is. Two big ferrite cores with the brass tubes that go through them and then 3 wraps of wires. So you have voltage comes through these 2 jumpers. Basically it starts out at the, your power jack comes down, comes across to, they're basically, I guess you could call it volted finals. So it's feeding directly off your power cord, but comes through these 2 jumpers. The tubes are soldered down to the circuit board on this side, and soldered down to the circuit board on this side. Now on this side of the circuit, on this side, it's just a continuous solder trace right across. All of this is all basically one piece. On the opposite side, it's broken into 2 circuits. So there's, so you can see it, there's a surface mount capacitor right here, is the only basically connection between the 2. So you have nothing in the middle. Like I say, you've got this ceramic chip capacitor here. This tube, which is the connection for your voltage source, comes across, soldered back down to the board again on this side, then goes to each of these finals. And you have the tube on this side, is soldered down to this side, and feeds the 2 MOSFETs on this side. Now, what I found is, if I can get the camera so I can get it all in shot here or not. So I've got move the radio back a little bit, that'll help some. Okay, yeah, right there is good. So, if we were to check, of course I now buried my probes, want leads. Okay, so if we go from this jumper, we should have basically a continuous connection the whole way to each of those traces, to each of those finals. So if we, I touch the pad, you can't see it, but I'm touching, come back just a hair. Trying to get all this in camera shot. So you see I'm just touching the trace there. You can see we have continuity. I touch this right hand tube, have continuity, come to the opposite side where it feeds out to the MOSFETs, we have continuity. We go over to this other side, there's nothing there. Go to the big pad right there, there's nothing there. I touch the tube on this side, there's nothing there. I touch the tube on this side, there's nothing. Well, we do have something. But if I let up off with my probe a little bit, as soon as I start to apply some pressure, I start to get continuity, and the harder I push, look at that, we have continuity. I let up, and it goes away. The transformer has broken loose, is what's wrong. At least part of the problems with this thing. So, if I push up from the underside of the board, because that does come through, trying to get a bird nest of wires here, you can see, they come through, so if I push up on the underside, I don't know how well it shows up in camera, that tube, the solder's broken loose. So it looks like that's a big part of my problem is I'm not getting any voltage to the, and that's why it was my voltage readings to these 2 transistors or MOSFETs over here. That's why they were, I think I said in the beginning of the video, I had some of my voltages back here were just all out of whack. Well, that's why they were out of whack. The voltages were fine to these 2, but the voltage to these 2 is completely bonkers. I'd have 0.2 volts, 8 volts, 3 volts, it just fluctuating all over the place. That's because this tube's not attached anymore So now I have to desolder these two wires, pull the wire out, because I can't solder directly to these tubes with the wires going through them, or I'll melt it. And that's the RF connection, because then the signal comes back out through the same path in through this output, because this is the output transformer. One side goes to ground, and then the other side is the signal out. Basically, this wire right here goes through these capacitors, and then across through all these coils, and then out through your antenna. But there's my problem, at least part of it. Like I say, so I need to get this transformer unwound, resolder the, and I'll remove the entire thing. I'm going to desolder the whole thing, clean these tubes up really good, and do a lot better soldering job on there. That, and I'll also use silver solder, which is has a higher tensile strength, so it'll be stronger, because we don't ever want that to happen again. So there you go. There's at least some of the problems. And then once I get that put back together, I'll put the finals back in it and see if see how it's working, if we have any increase in power. Okay, and really quick before I clean this up, as you can see, obviously, I don't know how well to show up in camera, but that's where, right there, kind of a dull gray, that's where it was broken loose. Just that little tiny spot there is what was holding it on. And if we look at the actual transformer tube, that's right where it broke off right there. I didn't really want to focus on the tube there, but that's where it broke off. So that was our problem. At least some of it, like I say. No guarantees that's all of our problems, but that's definitely going to be causing havoc in the RF section. So I'll get all this cleaned up now, get all the original solder, all of it removed. One other thing was, when I pulled this wire out, it dawned on me, somebody's been working in that area, because these wires were laid down flat on the board. They weren't soldered in. Well, there's through holes here, so somebody has had this apart. At least, I don't know if they had the windings out, but at least had pulled them up out of the board and just soldered them down on top. So yeah, like this thing's had work done to it. Okay, so the radio's pretty much all back together, except for the fan, which is the cooling goes right over top of this area. I'll be putting that back in. Just wanted to leave it out now so I can show you a few things. Those radios back together. You can see it's turned on, and it does work now. So it was either, and like I say sometimes, a lot of times when you get a radio, especially if it's something that's been through Lord knows how many different techs and people trying to fix it, and nobody can seem to get it working, a lot of times it's best to take the shotgun approach. Anything that's questionable installation wise, that's why I removed the 4 finals. I could clean up the pads, make sure there's no shorts. I showed you, like the solder paste residue, where there was a lot of unmelted solder still, captured in a lot of the flux residue on the bottom. Clean all of that off. Repaired the thing was one of the biggest problems was the tube for the output transformer. The solder connection was broken loose, so only 2 of the MOSFETs over here were getting power, and these over here, it was a bad connection. So if you own one of these, for starters, it might not be a bad idea just to pop your cover and see how well those are soldered on. If it looks like there's barely any solder holding these little tubes down to the circuit board, it wouldn't hurt to unsolder those either end of that wire, uncoil it out of there, pull it out, resolder those tubes down to make sure they're down and good, and you never have to worry about them coming off, and then wrap the wire back through. It's three times around, and then back down to the circuit board. Excuse me. But quality-wise, I think the board, like I say, it looks like it's pretty well made. I'd actually have to give Stryker a thumbs up on the manufacturing, at least, of this radio. Like I say, the quality of board looks like it's a nice quality board, nice silk screening, which kind of makes it hard to work on if you don't have a schematic. Which I think is what was one of the things that was killing a lot of the people trying to work on this radio. Nobody had a schematic. Well, I'm lucky I do. So here is the schematic, and it also helps that I have a large format printer, so anytime I need a schematic, I can just, if I get the file, I can just print it out large format, because trying to look at these things on a single 8.5 by 11 piece of paper is almost impossible. So But like I say, so I have the schematic for this, and also the board layouts. So, makes actually finding it, because some of your major components are marked, but nothing else is. 'Cause the parts you have to remember, surface mount, once you get down in size so small, it's actually hard for them to silkscreen part numbers for all those parts on there, because there's just no room. So yeah, it really helps to have the the parts layout and everything. So and there's the bottom side of the board, all your trace layout. So actually the tray end of it, that's the thing. A lot of this stuff you can't see because it's halfway hidden by solder, or by masking. So, but one thing I did want to cover on this was I didn't want to transmit with this radio too long, because I have not adjusted the bias yet on this. So I just want to really quick cover that, because adjusting the bias in the final circuit on this radio is a little unique. First thing, do not connect your amp meter directly to the radio. At least one of the leads. So what you're going to do is take a 10 ohm 1 watt resistor, and you're going to hook that up in series with your amp meter. So it doesn't matter if it's the negative or positive lead, you just need to make sure you have a 10 ohm 1 watt resistor in series with your amp meter. You're going to remove 3 jumpers, J101, 102, and 103. So you're going to remove this jumper, and this jumper. They're just little black push-on guys. Okay, they're little shorting bars that go onto pins that stick up out of the board. Now what I do is, I've just trying to hook up to those with test leads. Yeah, I'm not going to say it's impossible, but it's a pain in the butt. So what I've done is I just use an old connector out of God knows what, and that's what I use for hooking up the stuff like this. So I can just hook that on there, and then the other end I just have the wire was stripped off and added a big blob of solder to be able to hook up my alligator clips to. But so remove those 3 connectors, and probably most importantly, and something else that makes this a rather unique bias adjustment procedure, is you have to remove a component. So if you look down there, you see a big electrolytic capacitor right here, okay? And there's what I call the final, and your driver, and then the actual amplifier stage. So in front of and out from the driver, okay? You come up here, you see there's a transistor, a surface mount style, right here. Okay, what you're going to be doing is removing capacitor C551. It's this small, right there on the tip, right at the tip of my pointer there, you'll see a little tan colored component. That's a surface mount chip capacitor. You have to remove that capacitor to adjust the bias. Okay, so out from the driver and forward, and then it's right off of the top lead, or the top tang of this surface mount transistor is that little chip capacitor. Remove that chip capacitor. Once you have that out, you'll be able to adjust your bias. So first you're going to adjust using VR502. You're going to hook up your little test jumper that you've made up to be able to hook up your amp meter to, make it easier to hook up the amp meter, with your 10 ohm 1 watt resistor in series. Hook that up there, mic gain turn down the whole way, and key your microphone. You're going to adjust this potentiometer here for 60 milliamps. Once you get that adjusted, pull your little test lead wire off and slide it over to either one of these, because both of these are actually the same. It's just because so much current travels through this trace, they didn't want to take a chance of burning out one jumper, so they actually have 2 jumpers in here. So just on one set or the other, but install your little test jumper wire, and you're going to be adjusting VR501, which is back here in the far left-hand, matter of fact, just slightly out of camera range there. VR501 is in the far back left-hand corner, and you're going to adjust that, and you key the microphone, and you're going to adjust that for 120 milliamps maximum. Once you get that, pull your little test wire off, reinstall the 3 jumpers. Most importantly, reinstall that capacitor that you removed. So be careful, don't damage it, or if you do, you're like me, I've got drawers full of brand new surface mount components, but so be careful when you remove that. You don't want to damage it because you have to reuse it. But reinstall that chip capacitor, and your bias has now been adjusted on your radio. So there you go. Like I say, it really helps to have service literature. It's so hard to work on stuff if you don't have, documentation when you're doing stuff, especially with this surface mount, components. Schematics are definitely a must-have nowadays. So there you go. There's just a brief repair on the final section of a Stryker SR-497HPC. Okay, so you can see it's back together now. Figured I'd show you on air what it sounds like here. Receive.
I'll come right back. Like I tell you, big brother, I talk to my time. Your radio talk to you. Blackjack, all night. Who was you? That kind of nigga time. No doubt about it. Break us up further to 12 within the woods, bring up the street. But why you... One for English or two for disconnect. Wine Jack, Texas, gone. I'm waiting for the boy to leave. I don't want to share my teeth.
In any case, seems to be a good receiving radio. I have personally never owned one. I may actually buy one of these now. Like I say, actually the construction, manufacturing seems to be pretty good on these. I'd like to get one and actually maybe tinker around with it a little bit and see actually how good of a performer they actually are, especially on reception, tinker around with them a little bit, see if any improvements can be made. But like I say, for a modern radio, not bad. Now, of course, this is not a sideband radio. This is AM, FM only. But for an AM radio, it seems to have a fairly quiet receiver. Now, I'm not sure about this. I'd actually have to look at the schematic, because up here it says noise blanker ANL. But down here it has off, noise blanker plus. I'm assuming the plus just means the ANL. I don't think there's anything special in their ANL circuitry. But, like I say, seems to be a fairly quiet receiver, so I will tell you one thing. As far as modulation goes on this thing, now, currently I have just a stock Cobra coffin mic hooked up to it. Absolutely nothing special, and not a power mic. Well, I'm here to tell you, I've got the mic gain set, you can see right there, like between 1 and 2 o'clock, with a non-amplified coffin mic. That's even almost a little bit too much. I almost need to turn it back to, maybe like 12 o'clock or something, because this really has some, built-in mic amp. It's very effective, I guess you could say. I had my normal bench power mic, A-Static D104M6B on it earlier, and wow, I had it turned down to like 1, and even at that, it was way too much. So yeah, you really don't need a power mic with this thing. Just a standard old microphone. If you're using it mobile, maybe a noise canceling microphone. But yeah, really no need for a power mic. So there you go. There's the repaired Stryker SR-497HPC.